All right, so what we got for today is we're doing composition of functions. And with composition of functions, again, if you're keeping up with notes, this would be number 9 for today. That with composition of functions, basically what you're doing is you're substituting one function in for the variable of another function. All right, and there's basically, and again, we're kind of doing what we're doing yesterday. Yesterday we were adding, subtracting, multiplying, and dividing two functions that were f of x and g of x. We're still going to stick with the f of x and g of x thing on this one, that f of x will be one function and g of x will be the other one. For this one, here's basically what it's going to look like. It looks like fog x. It looks like it's f o g, but it's actually, it's like an open circled multiplication dot is really what that one is. Okay, so there's one way they can show composition. They may also give it to you so that it looks something like that. Those two things basically mean the same thing. In some books, use one more than the other. Our book kind of goes back and forth on those. So if you see either one of those two, just realize that both of those mean the same thing for this part of it. Okay, and then the other, and so that's where we've got with the f function first. They will also do the same thing with the g function first. So you got what looks like fog x. This one would be what looks like golf x, but that's not really what it is. If you actually were trying to read this one, if you actually had to like read it out, you would read this as f of g of x. So it's f of g of x. It's not again, that's just, if somebody was going to read this out of the textbook, that's kind of what you would read that one. This one, you would read it the other way around. This one, you would read this as g of f of x. Okay, and now here's the big thing that I kind of figured out for this one when I was going back and being in y'all's shoes and doing some different things on this one. What finally made this click, because I always kind of struggle with this one a little bit, what finally made it click for me, and I had to go back and kind of talk to my high school math teacher when I was doing this one. I think in college I kind of had a spot where I kind of spaced out on this one a little bit. And when I started teaching it, it seemed like something that clicked, especially college-wise, was actually to write down some math on this, or some English for this part of it. That when I'm reading this one, this means that you're going to plug g of x into f of x. And I don't know why, for some reason, for me, it clicked to just write down that one simple little easy sentence. And once I did that, then it made things click. Over here, this would be the opposite. This one, we're going to plug f of x into g of x. All right, so let's show you what all that means for this thing. All right, so let's say that f of x is x plus 2. And g of x is 4x minus 3. And we're going to go ahead and find both of these. We're going to find f of g of x, then we'll find g of f of x. Okay, so they'll give you the two functions. Here's f of x, here's g of x, and then they're going to tell you to find some. I can't remember some of the questions. It may ask you just to find one. Some of it may do both. So we'll go ahead and go through both of these here. All right, now this is the part that I always kind of struggle with this a little bit, and it was just writing down one simple little thing for this one. And I remember teaching at Calhoun. This was a few years back. I had a lady that was taking this math class, and she was teaching at a private school, and she was working on getting her math degree. And she was like, "Well, I'm teaching this, and it's not clicking." I'm like, "Well, try this." I said something really simple, and maybe this will work. That whatever's closest to the letter that's here. So we're going to plug f of x into g of x. So you always start with what's closest to your x variable, whatever variable they give to you. You start with a function that's closest to that one. So x is closest to f, so we're going to start with that one. And then what I had them do was I said, all right, just write down what those two things are. F of x is x plus 2. G of x is 4x minus 3. And so I had people, and this was something I started doing, and it made it click. I circled the whole thing here, and everywhere you have a variable here, you're going to go back and plug it back in for that variable. So this was going to be 4 times, instead of x, now it's x plus 2 minus 3. And then once you take out the variable and plug in the function in its place, well, from there, you just work this thing out and see what you can come up with. You've got 4 times x is 4x. 4 times 2 is 8. And then the only thing left to do then is do the 8 minus 3. So that's going to make it 4x minus 5. Okay, so when they're talking about these questions.
What would it be minus 5?
Oh, I'm sorry. Plus 5. Thank you. Sorry about that. 4x plus 5. Sorry, I wasn't paying attention there. Right. And then if we reverse it, if we'll do part B, we'll kind of go back around this one. We're going to find, if that was g of f of x, this time we're going to do reverse order. We'll find f of g of x. So we're going to plug g of x into f of x. All right, again, g of x is 4x minus 3. F of x is x plus 2. Okay, and again, the whole thing goes in place of the x. All right, now, and again, depending on the problem and how they set this up, this one, when you plug it back in here, it doesn't really do a whole lot because it's 4x minus 3 plus 2. Well, there's no distributed property. There's nothing with this thing to really do. So it's just plain, it's just 4x minus 3 plus 2. So doing the minus 3 plus 2, that'll make that negative 1 or minus 1. Okay, so there's the basics of what you're going to do. So it's just taking one function that you're given, and you're taking that function and you're plugging it in for x into this other function that you're given for what's there. All right, is everybody okay with that one? Seem like so far so good? Okay. Let's show you one that's a little bit tougher, just so you can kind of see what it's going to look like when you do this one. And then we'll get a feel for that one. If you can get through the toughest one here, then there's not really, if you get through the bad one here, there's not much else we can do that would throw this thing off by any big stretch of the imagination for what we're going to do. All right, so for f of x, let's go with x plus 5. And g of x, let's make it x squared minus 3x plus 2. All right, so for part A on this one, let's find f of g of x first. Okay. Again, depending on which question, how the book goes to this one, they might give you this. They may also give you this. So again, it just depends on. Sometimes it's this one, sometimes that. It still means the same thing no matter what you do for this one. Biggest thing is for this part though is that you're going to plug g of x into f of x. And again, I can remember just writing down that one little sentence like that, and for me that just it clicked that because I was a visual person, and once I could write it out, I could see, okay, I'm going to take x squared minus 3x plus 2, and that's going into x plus 5. Okay. All right. Excellent. Let me make one small change here while we're doing this. If I get too far, make this 2x plus 5 for me. Okay. So that's 2 times x squared minus 3x plus 2 plus 5. All right, so a little bit of distributive property. So it's 2x squared minus 6x plus 4 plus 5. So the only thing you can do for this one is once you've done distributive property with a 2, just do the 4 plus 5 and make it 9. Okay, and you may be going, well, that wasn't too bad. That was a lot like the first one. It was. All right, here's where the change is. This is where the tough one kicks in. So if you can get this part, then there's really not much else they can do that should throw you off on anything that they're going to see for this part. If we reverse it around and do g of f of x, again, they may give it to you like that. It may look something like that, but that's either one of those two is what they'll do for the second part for g of f of x. Main thing is that you're going to plug f of x into g of x. Okay, so we're going to take 2x plus 5, plug that into x squared minus 3x plus 2. All right, here's what makes this one a little bit more difficult. Because you're going to plug it in for x here, and you're also going to plug it in for x there. So now, because there's two x's in this part of the function, you've got to plug this thing in twice. So it's 2x plus 5 squared minus 3 times 2x plus 5 plus 2. Okay, and and again, it's not necessarily plugging in twice that makes this one hard. Here's the part that makes it, it's not really hard, just makes it longer. When you've got 2x plus 5 squared, that means you're going to have to do the full method, which means you have to write that one out as 2x plus 5 times 2x plus 5. All right, and then we've got to go back and do the full method through this thing. So if we do that, we've got to do 2x times 2x and 2x times 5. So that'll make that 4x squared. For the 2x times 2x, 2x times 5 would be 10x. All right, bottom side, 5 times 2 is another 10x. 5 times 5 would be 25. And with the full method, again, most of the time when you do the full method, your middle two terms you can combine together. Same thing for this one. Combine the two together, do the 10 plus 10 to make it 20. So we've got 4x squared plus 20x and then plus 25. All right, now that's just the full method part. We still haven't done anything with this part back here. So the first thing we're going to do is do distributive property. So we'll do negative 3 times 2x, which will make that a negative 6x. Let's put that right here. Then we've got negative 3 times 5 for negative 15. And then you've got this plus 2 that's kind of tailing in behind it. All right, so we've got the negative 6x here. Go ahead and do negative 15 plus 2 to make that negative 13. And then you can pull those parts in behind this one, and then now you've got to combine all the like terms here. So we've got the 4x squared, which is good. You've got the 20 minus the 6 on the x's. So doing 20 minus 6 would make that a plus 14x. And then the last piece there, you've got the 25 minus 13, which would make that a plus 12. All right, and it's not necessarily that it's harder because, I mean, it's doing stuff that y'all have done for years. You're doing the full method, you're doing distributed property, you're combining like terms, you're doing all those things. It's just you've got to, it's longer. It's not necessarily, I mean, it is a little bit harder because it's you know, you got to do the full method with it. But it's not like anything like super hard. It's just, it's a little bit more involved to kind of get you through the answers on this one. So the best, I guess the thing to look for is if you're plugging something in and you've got x squared, that's when you got to do the full method. That's what's going to make this one go a little bit longer. If it was just this part back here, you know, this part wasn't bad. There's a little bit of distributed property, and then you combine some like terms. It's the full method that makes this one go a little bit longer. But that's as complicated as a problem as what you're going to see. You're not going to have anything that gets anything more in depth than that one when we go through the parts on this one. So if you're okay with that one and you're like, well, you know, it's not too bad. If we didn't blow you out of the water, then everything else that we're going to do should be fine for that part. Okay, so that's the first part of composition of functions. The second part of composition of functions is where you actually have numbers to plug in. And let me kind of back up for a second because I don't know that we had done this. Y'all check with me and see and remind me. Did we talk about evaluating a function? Does that ring a bell? Anything at all? That if you had, let's just make up something here for a minute. If you had f of x was equal to x squared minus 6x. Did we ever do anything something like that where you had to find out what f of negative 2 was? Is that ringing a bell at all or no? Maybe we did it. Maybe it was a long time ago. I don't. Maybe it was. Okay, I was thinking we did it, but I can't guarantee it. So I'm thinking maybe we did this a long time ago. So anyway, let me just back it. We'll do this just for practice, just to make sure everybody had it. If you're given a function and they tell you to find a number, then all you're going to do is you're going to take the function that you have that's here, and everywhere you have that variable, you're going to just take out that variable and you're going to put that number in its place. So for this one, you would take out the x, you would put in negative 2. This one, you would take out the x, and you'd plug in negative 2. Everything else around that, the squared and the minus 6, that all stays just like it is. And when you go through that one, once you the f part of the function that's over here, you don't really do anything else with this. This is just telling you what number to plug in. Everything else you do it on the right-hand side over here. So you go ahead and do your exponents. You do negative 2 squared to make it 4. Then you've got negative 6 times negative 2. That would be a positive 12. So then you do 4 plus 12, and that would be 16. Okay, and I was thinking we had done that, but I couldn't remember because the normal flow with everything with PLP hasn't quite gone like it normally is. But so I was thinking we'd done that. So, you know, if you've got to evaluate a function, they give you the number to plug in, and for the f part of the function, that's kind of like this is like y equals. That you're just plugging this number in and you don't do anything with the left-hand side up here. All the work is over on this side of the function that's over here. You don't do anything with this number other than just plugging it in and replacing the x. But as far as like doing anything else with it, you just ignore it and you just work out the right-hand side over here. Okay, and again, I was thinking we had done that, but I just wanted to make sure. This year's been so crazy that you can't always keep straight everything that we're doing. Okay, so if that's kind of ringing some bells, if you're going back and thinking, okay, I kind of remember doing that, this is what we're going to do for the second part today with the composition with the functions. That we're actually going to, it's composition of functions, but this is composition when they actually give you a value. So it's still composition of functions, but it's going to be given value. So it's going to be doing a lot of what you did back here. You're just going to be plugging numbers in and working this thing out. All right, they'll start off with pretty much the same thing, that you'll have two different equations or two different functions. And what they'll do for this one, it's going to look pretty similar on this part, and we'll do like an A and B on this thing. They're going to tell you to find f of g, so that part's going to be exactly the same. Here's the difference. Here's where the given value comes in, is that now they're going to say, all right, take this equation you have, this composition function thing we've got, and instead of it just being x, now they're going to tell you to find -3. And that's the biggest difference. If you're going to have x like it was back here, they just tell you to find g of f of x, so that your answer is going to look something like an equation. If they give you a number, now we're looking for like an answer that you would get from this one. And there's basically 2 steps on this thing that you're going to do. So step 1 is you're going to evaluate the value into the function it's closest to. And remember, evaluate just means you plug in and solve. I may not be saying it the best, maybe a little overkill on what we're saying there, but I want to make sure we got it. So you're going to evaluate the value into the closest function that's to the value. Okay, so here's -3, and it's closest to g, so we're going to find g of -3 first. Okay, so the way we'll do this one is the red will be the steps, and then the blue is going to be the directions, and the red's where we're going to work this thing out. So we're going to find g of -3. So that means for g of x is equal to x squared, we're going to plug in -3. So we've got f of g of -3. So we're going to take -3 and plug it into g because that's the one it's closest to. All right, so -3 squared is 9. So for that answer, that's going to be 9. Okay, and we kept this one short just so you won't see a whole lot of it. We'll get one in a second. We'll do one where it's a little bit longer. But I want to keep this one kind of short so you won't have to see a whole lot to it. All right, and here's basically what we're doing for this part of it. Once you've got g of -3, that we're basically taking this thing that's here and canceling this part of it out. Since g of -3 is the same thing as 9, now we're going to take this thing out and we're going to put 9 in its place right here. So now we've got, all we have left is f of 9. So step 2 is you're going to take the answer from step 1 and evaluate using, we'll say, the other or unused, remaining, whatever you want to call it here, the other or the remaining function. Okay. So, and again, it's just basically crossing one thing off. We've already done g of -3. We did this one, so now this thing is done. We're going to replace that with 9. And once we've got the 9 there, we're going to take that 9 we have, and we're going to plug it into whatever function is left over, which would be the f function. we're going to take this 9 that we had here. We're going to plug it into the function that was left over, which was the f function from back up here. So we're basically going to find f of 9. Okay, so f of x was x minus 5. So f of 9 is just 9 minus 5. Okay, and then that's going to be our final answer. Okay, so it's a basically just a two-step evaluate. You take whatever answer, take the number you have that you're given, you plug that into the function that's closest to it, and that kind of crosses out that first part of it. And then there's only one thing left to do from that point, and then you take that number and plug it back in, and then we'll go from there. Okay, now let me give you another one of those just so you can kind of practice with it and see what's going on. We'll do one more of these, and if everybody's okay with this one, I'll show you the one thing that kind of throws some people off a little bit, and that'll be the last one we'll do for the day. All right, so let's say f of x is 3x plus 7, and g of x is, let's go negative, negative x squared plus 3. I always like showing one of those like that because it's always got a little twist to that one. All right, so let's find g of f of, and somebody give me a number, one that's not too big. 35 is way too big. 3. All right, we'll go with 3. All right, that works. All right, so we're going to find g of f of 3. All right, so step 1, to me, that's always the easy one because you take the number that it's closest to, or take the number you have, it's closest to f, so we're going to do that one first. So we're going to find f of 3. All right, and again, I always kind of like to me, it was easier if I wrote out the function and I wrote whatever number it was I had to plug into it. For me, that was really easy because everywhere I've got an x, that x has got to come out, and I got to put a 3 in its place. So that's 3 times 3 plus 7. And again, once you plug in this 3, the right-hand side is all the work you're going to do. You don't do anything with the left-hand side. 3 times 3 is 9. 9 plus 7 is 16. And this is going to be big anyway, but it will be okay. Okay, now once you've done that, now you've done this f of 3 part that this thing is done, and we're going to take f of 3, and you replace that with 16. So now we're going to go back and put that 16 in place of f of 3. So it's going to go in basically like that. So now we've got g of 16. So then step 2 is we're going to take this answer of 16, and then we're going to plug it into g of x. So g of x is negative x squared plus 3, and we've got to find g of 16. Oh, sorry. Bring up this. Okay, because again, once we found out that we did the f of 3, now this part is gone. It's out of the way. The only thing left then is g. So we're going to take this 16 we've got, and we're going to plug it in to the g function. All right, now, and I picked this particular part of the function here on purpose because you got to be careful. When you got the negative, you have to plug the 16 over here. If you notice, the x's and the 16 is in parentheses. When you plug in the 16, make sure it's in parentheses. All right, and again, this is one I like picking this one on purpose because where that negative is makes a difference in the answer on this thing. And if you don't set this thing up right for the part when you plug it in with the calculator, it's going to give you the answer in the wrong way. So if we do the negative of 16 squared plus 3, we're going to get negative 253. Because what we're doing in this case is that if you go through the order of operations, you're doing 16 squared first, and then you're going to go back and put the minus sign in front of it. So it's going to be this 16 times 16 would be 256. So that's the negative of 256 plus 3. And sometimes that throws people off because they're like, well, I thought it was a negative times negative. In that case, it's not, because the negative is on the outside of the 16. If that negative had been on the inside, then it would have been a negative times a negative. We'd have done it twice. But the negative on the outside means you really only do it once. So then final answer on this one would be the negative 253. Okay, now let me show you one that this is one that sometimes throws people off a little bit. And it's not really, once you see one, you'll go, oh, well, that's not bad. It's just sometimes seeing one to kind of make sure that you know what's going on here. Because sometimes this will throw people off a little bit. Let's say that f of x is 5x minus 6. And g of x is 2x squared minus 4. Okay, that may do something like this. That may tell you to find f of negative 3. Because usually the part that throws us off, everybody's like, well, okay, what do we do with g then? Even if they give you two functions here, if they don't do anything with g, then you basically just ignore that part of it. It's just not even there. So all you're going to do is you're going to do the f of negative 3 first. So we're going to go ahead and do that part first. So we're going to do f of negative 3. So f of x is 5x minus 6. So we plug in negative 3. That's 5 times negative 3 minus 6. So negative 15 minus 6, that's going to be a negative 21. Okay, and a lot of times people get that one, they're like, oh, what do we do with the next one? Well, now that this thing is negative 21, you've already done this thing out. You're going to plug in negative 21 here. Now you're going to do f of negative 21. So then you're just going to reuse the f functions. You're going to plug it in twice. It's like having, is it twice baked potatoes? That you bake it once and then you go in and you mix it up and then you bake it again. This one's kind of the same thing. You take the negative 21 now, and you're going to plug negative 21 into f of x. So you're going to plug it into the same thing twice. So you're going to take one number and plug it back in. Then you're going to take that answer, and then you're going to plug it back into that same function again. So if they give you the same function twice, you take this answer, and now you're going to plug it back in again. So f of x was 5x minus 6. We're going to plug in negative 21. So that's 5 times negative 21 minus 6. Okay. And again, it's not hard. It's just sometimes it throws people off because like, what do they do with the g? Well, they didn't do anything with it. It's just there just to throw you off to see if they can trick you in this case. 5 times negative 21 is negative 105 minus 6. So final answer in that case would be a negative 111. All right, so with compositions, that's your two choices. Either they're going to give you a number to plug in, and really that one number means you have to plug it in twice. You're going to plug it in first here, and then you're going to take that answer, and then you'll plug it back into whatever function they give to you. Or they're going to give you just an x variable, and if they give you the x, then you're going to have an answer that's going to finish up looking something like, 2x squared minus 4 plus whatever it's going to be for that thing. So again, they give you a specific number. You need a number answer. If they give it to you where you've got x in your composition, then you're going to have x in your answer, or t, or whatever variable they give to you.